Hi and good evening. We are from Group 2. We'll be presenting the lab simulation for PHY636. Our group consists of 3 members. I am Nurul Husni Shawani binti Sharul Nizam, and my group members are Nur Zahidah binti Saleh and Nurul Nafizah binti Sulaiman. I am going to perform task 1, conventional logic circuit, binary input and output F. Task 1, write your number in the group list. The number is binary and your answer of output F in manual page 15 after you insert your binary number. A is the first digit and E is the 5th digit. From the picture, the first one shows that the AND gate with 3 input and the OR gate with 3 input is connected and it comes out with 1 output, which is F. So the first one shows that if the input is 1, so the output is 1. And the second one shows that if the input is 0, so the output also 0.
Hi, my name is Nur Zahidah binti Saleh. In this video, I will be demonstrating task 2, creating a breadboard drawing for our assigned OR gate. First off, here we have OR gate, input A, input B, output LED, resistor, and power supply. To build the circuit, we will arrange the components first. Okay, now we will connect the positive terminal of the power supply to the breadboard. Make sure the red wire is used as positive. After connecting all the red wires, we will proceed to black wire as negative. Same as previously, we will connect the negative terminal of the power supply to each component in the breadboard. Now, for each switch, we will use different color of wires. In this case, I will use green wires to connect switch A with input 1 and switch B with input 2. Then, purple wire as output that connects to the resistor. Finally, we are done with our circuit. Now, we will run the simulation. As we can see here, this is LED output. When input A is 0 and input B is 0, the LED is off, which means output is 0. When one of the switch is turned on, the LED is on, which means if any input is 1, the output is 1. Then if all input is 1, the output is 1. To sum up, our circuit is correct according to this OR gate's function. So this is final look for our schematic diagram.
So I will continue with task 3, which is construction of combined AND or OR gate circuit on breadboard with LED output. Task 3, draw the breadboard for circuit in page 12. So this is how task 3 is being done. the truth table for task 3.
Hi, my name is Nurul Nafisa binti Sulaiman. I'm going to perform task 4.
In this experiment, we use simulation to design and test a circuit where an Arduino Uno controls a 7-segment display through a push button. The 7-segment display has 7 LEDs labeled A to G, and the Arduino sends signals to light up the right segments to form numbers. For example, when we press the button, it displays the number 2 by turning on specific segments. The objectives are firstly to prepare the breadboard drawing of 7-segment display using logic circuit simulation. Secondly is to simulate and demonstrate the interfacing of a 7-segment common cathode display with an Arduino Uno to display the digit 2 using a push button as an input trigger. Simulation tools like Tinkercad help us visualize the circuit, check our connection and test the code without needing physical components right away. First and foremost, we prepare the breadboard and then we prepare Arduino Uno R3 as the controller for our circuit. Next, we prepare a 7-segment common cathode display. Place the 7-segment display on the breadboard. Ensure 2 rows of pins straddle the center gap of the breadboard. Then, we prepare a push button as an input trigger. To limit the current through each LED segment and prevent it from burning out, we use the resistors. Ensure your breadboard power rails are properly connected to 5V. Connect each segment pin through a 1 kilo ohm resistor to Arduino pins as per schematic. Arduino pin 8 is connected to 1 kilo ohm resistor which will light up segment C. Arduino pin 7 is connected to 1 kilo ohm resistor which will light up the segment E. Arduino pin 6 is connected to 1 kilo ohm resistor which is segment B. Arduino pin 5 is connected to 1 kilo ohm resistor which will light up segment A. Arduino pin 4 is connected to 1 kilo ohm resistor which will light up segment D. Arduino pin 3 is connected to 1 kilo ohm resistor which will light up segment F. Arduino pin 2 is connected to 1 kilo ohm resistor which will light up segment G. Connect the push button one leg to D11, the opposite leg to ground. In a common cathode display, the common pins are connected to ground and segments light up when a logic high voltage is applied to the segment pins. This is the Arduino coding to display number 2 in countdown from 0. We figure out that there was a faulty connection at the pin number 2. As a solution, we connect the pin connection to 1 kilo ohm resistor to light up the segment G. Arduino controls a 7-segment display to show numbers when the push button is pressed. Pressing the button cycles the digit. After 2 presses, digit 2 lights up. Segments A, B, D, E and G illuminate correctly. The circuit successfully interfaces a 7-segment display with Arduino to display the digit 2. The push button effectively serves as input to cycle through number as designed in the code. Segments light up accordingly because of the digital write commands. When the button is pressed, V_BN reads high, which is 1. The counter increments. When counter equals 3, the 2 double bracket function is called. Then it will light up the segment A, B, D, E and G, which will display number 2. Here's the truth table for a common cathode 7-segment display. A to G represent the segments. 1 is when the segment is on, 0 is when the segment is off. To display the digit 2, the segment A, B, D, E and G is 1, while C and F is 0. We now come to the end of our lab simulation video. Thank you for watching.